So on the unit exam, you have to make connections, okay, on many of the questions. And by make connections, I mean there's a lot of material. I shouldn't say a lot. This is actually the shortest unit significantly. Okay? This unit exam is worth the same amount as all the others. There's way less material on this one than there was on any of the others. But on this one, there's more connections between that material. There's a lot of overlap. You will probably use some of the same concepts multiple times, okay, on this exam. Okay? And I don't just mean in the multiple choice and the written response. I mean, you might use the same concept in 3 written response questions. And that's okay. That's how much connection, interlocking, interlacing, overlap of concepts there can be. So, very much like biology, there's some writing on this test where you have to do a lot of explaining, okay, and demonstrating to me where is your level of connection for these concepts. Okay? If you write very little, then there's not going to be as many marks for you. If you show that, hey, Mr. Coderre, I understand how these 2 things are connected and how they relate to this question, then, oh, okay, that's really good. I'm really looking for that kind of thing. So I'm going to talk a bit about that as we go through some of the concepts and just kind of review with you how they're related. Okay? What you should do as we're going through that is make note of how I'm going to ask that. Okay? And maybe make note of what things might be on here multiple times. Okay? How they might work into more than one question. Okay? So level of detail is going to be important on this test, okay? If you think it fits, write it in, it probably fits. Okay? When in doubt, write it in. Okay? All right, so the first concept we went over was climate, okay? And we went over the 4 components of climate, okay? Temperature, precipitation, light, and wind, okay? Certainly those are important, okay? And then we also went over the factors that affect the components of climate. In fact, you handed in an activity where you looked at climate graphs and then you had to interpret from those climate graphs and from looking at Google Earth what you thought would be the main factors that affected the climate of those cities, and you had to explain to me how. Do you suppose I'm going to ask something very similar to that on the exam? I definitely am. In fact, the day we went over this, I told you exactly how I was going to do that. I'm going to let you finish what you're writing, and then I'm going to tell you again. Okay, so on the exam, I'm going to do basically the same thing you had to do in the climate graph activity, minus the climate graph. Right? I'm going to put a map of Canada in this question, and I'm going to put an arrow on that pointing at a specific city. Okay, just in case your Canadian geography is, not so good. Right? But I'm going to point an arrow at that city, and it'll be a city that's fairly easily interpreted. Okay? And here's what I'm going to ask. Using your knowledge of factors affecting climate, describe what you think the climate of this city will be like and explain. Okay? It's a 5-mark question. So let's say I pick Calgary. Just spoiler alert, I'm not picking Calgary on the exam. Okay, we're using it as an example today. I would say, just like on the assignment, you should probably pick 3 factors that you think most affect Calgary's climate. What would be a good bet for those 3? What was one I said you could use for any city? This is a big spoiler. Latitude, yeah, okay. Doesn't matter what city I pick. Distance from the equator affects, well, basically all of the components of climate. Sidebar, should you probably mention all 4 components of climate in your answer? Is that demonstrating connection? Definitely. Okay, so if you say, well, latitude would be a primary factor affecting Calgary's climate because it is very far from the equator and would thus experience seasons, or like maybe say distinct seasonality, okay, where light and temperature would both fluctuate throughout the year. Okay? Another factor affecting Calgary's climate could be, what else? Mountain barriers, definitely. Okay, and then you could say, the Calgary is kind of tucked in right behind the Rocky Mountains. which create a rain shadow, which limits the amount of precipitation Calgary receives, making its climate on the dry side. All right, well, I've covered all 4 components of climate. Well, sorry, I haven't covered wind, but I can cover wind right now, and I could have covered it with latitude as well. Okay? Is Calgary's latitude put it in the prevailing westerlies? We're thinking about global wind patterns. Could have talked about it there. Okay? But I could also talk about how being close to the Rocky Mountains creates Chinooks, which are a warm wind structure or mechanism, okay, that creates warm, dry conditions, okay, on the prairies. And then maybe a third factor could be, what do you think? Maybe altitude? Right, I mean, our altitude here is like right here in this school is 1,096 meters above sea level. Okay, that's significant. Temperature cools 6 degrees for every 1,000 meters you go up, so all right, we should be 6 degrees cooler, okay, being at around 1,100 meters. So that could certainly be something that affects temperature. It could even affect precipitation, okay, stuff like that. All right, does that sort of make sense? So I'm looking for quite a bit of writing there, and I'm looking for quite a bit of connection between factors affecting climate and how they affect the components of climate. Okay, and it's going to be for a city somewhere in Canada, okay, and you're going to have to make those connections. Does that sort of make sense? So do you have to definitely know then the 7 factors and the 4 components? And you got to memorize those, okay? But you can't just regurgitate them on the test. You're going to have to apply them to that situation, okay? All right, questions on that? Could the factors that affect climate and even the components of climate end up in some other questions as well? Yeah, they could. Could they be in the multiple choice? Yeah, it'd be pretty easy for me to make a question like this. Which of the following is not a component of climate? Temperature, proximity to oceans, wind, and precipitation. Right? Just checks to see if you know the difference between the factors and the components, right? Proximity to oceans would be the correct answer there. It's a factor that affects climate, not a component of it. Okay? Easy to put that in the multiple choice. I could also put in a situational question like, if you were in Iqaluit, Nunavut, what factor would most affect your climate? A, proximity to the oceans, B, presence of mountain barriers, C, latitude, D, centers of high and low pressure. Probably would pick latitude, right? Something like that. Probably pick something more obvious. But okay, second thing we went over, climate graphs. Okay, and as we said yesterday, your job with the climate graph is that you will be asked to match it with a biome and explain. To do a good job of this question, one of the things you would have to do is interpret the climate graph. Okay, look at it and tell me, what is the climate of that area like? Is that going to go back to components of climate and possibly factors affecting climate? Would you agree? Like, let's say I was to give you a climate graph that had a flat temperature line that stayed somewhere around 28 degrees, and most of the months had no temperature bar, and there were a couple of them that had temperature bars that went up to like 5 to 10 millimeters, and the rest were nothing. Okay? What would you say about that climate? Okay, if the line is flat, where is it? Near the equator. Okay, did you just mention a factor affecting climate? Right, in your answer you would probably say this would appear to be some place that has a low latitude or is close to the equator. That would be same as saying latitude. And so as a result doesn't have differences in seasons. Okay, and according to the precipitation bars, this place appears to be very dry. So there's very little precipitation, and the temperature is very warm and steady. Okay, that means that this is probably what biome? I would say an equatorial hot desert, yeah. Okay, and then you'd have to defend your choice. So then you would talk to me about what a desert biome is like. Okay, desert biomes are typically very dry. They would only have, some scrubby vegetation, and they can be found behind mountain barriers and things like that. Like, again, you can work in those factors affecting climate into that question. This is, again, where if you do that, if you can find ways to connect ideas, that's showing how well you understand something. The more connections you make, the better you understand it, and you're demonstrating that to me by doing it. Okay, sort of makes sense? What I'm looking for there? I want you to make those connections. I don't just want, it's a desert because it's hot and dry. Yes, good, but, and what else? Okay, all right. Then we went over energy transfers in global systems. This was the lesson full of threes. Appropriately, it is also number 3. Okay? And on your lessons, it was lesson 3. It was everything in threes that day. It was the trifecta. Okay? So, the 3 parts of the earth, what were they? Atmosphere, lithosphere, hydrosphere. Okay, all the air wrapping around the earth, all the water on the earth, including the water cycle, okay, and all the rock, earthy parts of the earth, the soil, okay, that kind of stuff. They all have a role to play in the global energy picture. Which one is most involved in transfers of energy on a global scale? Anybody remember? Which one's the easiest to move?
Atmosphere.
The atmosphere. Okay, in the atmosphere, is there, what heat transfer method is most involved in the atmosphere? Okay, right now if you're feeling lost, these are the connections I'm going to need you to make. Okay, in this lesson, we talked about the 3 parts of the earth, hydrosphere, atmosphere, lithosphere. Then, we talked about the 3 fates of light: absorption, reflection, and conversion by plants using photosynthesis. And then we talked about the 3 methods of heat transfer: conduction, convection, and radiation. These ideas all tie together in several written response questions. Okay? So, right now I just asked you, which part of the earth is most responsible for transferring energy? The answer is the atmosphere. Okay? Why? Because the atmosphere is the most fluid part, and convection can occur very easily. Convection is the transfer of energy by currents. That's moving air, which we call wind, and wind can help move not only sensible heat, but also, what kind of heat? Latent heat. Okay, you see all the connections that can be made in an answer for that question? Okay, that's the difference between, the atmosphere, because it can move a lot, versus the atmosphere undergoes convection, which transfers energy, which moves latent heat, and there's wind mechanisms like the jet stream. Wow, suddenly it goes from 2 to 5. Okay, it's the connections, it's the level of detail, okay, that show me I know this at a 5 out of 5 level Coderre. Put a 5 on my answer. Okay, I want to put a 5 on your answer. Give me 5 marks worth of connection. Okay? All right, what was the special word that we used to describe how much energy would be reflected or absorbed?
Albedo.
Albedo. Is that an answer? Is that a word that should be in your vocabulary and should appear in several questions' answers? Definitely. Okay, it is huge because it does in fact determine the 3 fates of light. Okay, now if albedo is high, that means it's very what? Reflective. Okay, albedo is the reflectivity. So a high albedo, lots of reflection, which means no change in temperature. Low albedo, lots of absorption. That means change in temperature. Things are going to warm up. And if it's covered in leafy little green things, then probably a lot of conversion will occur. Okay, I'll give you a chance to write that down. would say that on this exam, there is probably a way to work the idea, concept of albedo into nearly half of the written response questions. Okay, we're talking about energy after all, and albedo is the determining factor to how much of that gets absorbed. Okay, that could be worked into you know, a global energy transfer question. It could be worked into a small scale energy transfer question. It is, after all, the determining factor. Okay? So here's one way. I told you this the day we went over this, but you've probably forgotten it, so I'll tell you again. Here's how I'm going to test this. I have taken a clip, a snapshot from Google Earth of a place on Earth. Okay? And I have placed it on the exam in that question. You will need to look at that picture. It is in color, by the way, because that's kind of important. Okay? And you will have to tell me what you think will happen to the light that strikes that particular area. Okay? Is albedo one of the things you should include in an answer for that question? Okay, should you explain to me how the albedo works? Okay, and then you should talk about the three fates of light. Okay, so yeah, there's some memorization here. Yeah, I gotta know those four things. But I also, ghost in the machine. Okay, I also need to apply it to that particular place. So let's say I showed you a picture of Antarctica. Spoiler alert, I have not got a picture of Antarctica on the test. Okay, what's Antarctica going to look like? Very white. Yeah, it's covered in a giant kilometer thick glacier. So what would you say about the albedo of that area?
Very high.
Very high. It's highly reflective, okay, which means very little light will be absorbed. A lot of the light will be reflected. Will any conversion go on? No plants. Yeah, but you should explain that, right? You can't just say no conversion will happen. Tell me why. Well, there's no plants, Mr. Coder. Look, it's all white. Okay, nothing's growing here. Those are the connections, again, the level of detail that has to be made. So obviously I'm not going to give you a picture of something quite that simple. Okay, I'm going to give you a picture and you're going to have to look at it and go, oh, okay, well, there's parts of this picture, most of it appears pretty dark or most of it appears pretty light in color, but there do appear to be some plants because this part of the picture is green. Okay, and just apply, talk. Okay, well, you know, some of it's going to do this and some of it's going to do that. You have to look at the situation and say what you think. All right, make sense there? All right, then we talked about this, okay, the atmosphere, it's the most fluid. Convection is the main method of heat transfer in the atmosphere, okay. The atmosphere and the hydrosphere, okay, they combine to move latent heat around using the water cycle and what wind mechanism? The jet stream. If people forget something, it's usually that. Okay, and then of course, the lithosphere's job is mostly to do with absorption. Okay, it can move energy by conduction, but that doesn't go very far. Its main role is albedo and providing soil for plants. Those would probably be multiple choice kind of things because they're mostly memorization. But there's definitely going to be stuff about how these two work together, okay, to transfer energy on a global scale. Okay, so if I ask you a question about, if I ask you to explain how energy might be transferred from a high energy area like the equator to a lower high latitude area like the North Pole, okay, are you going to have to integrate a lot of things into that answer? probably the most of any other question. Okay, because so many things come into play on a question like that, right? What's the main mechanism that's going to carry energy from the equator to the poles? Convection, okay, within the atmosphere. The atmosphere is going to have the biggest role to play. Okay, you got to talk about, you know, hot air rises, cool air has to move in to replace it. That's convection, and that's going to cause this. And then as the air moves northward, maybe evaporated water from the water cycle is carried with it, and that's going to bring, what does evaporated water bring? What kind of heat? Okay, is that something that should be worked into a global energy transfer question? Definitely, it's huge, right? And then you can also say, you know, the jet stream has a role to play in moving latent heat around. You got to tie a lot of ideas together in a question like that I'm, spoiler alert, totally going to ask. Okay? So lots of ideas there, level of detail. If you think it applies, write it down. Okay? But make as many connections as you can. Work in as many concepts as you think fit. Okay? Find a way to put them in there. And don't just write convection. If it doesn't fit, like you just like, I wrote convection coder, yes, but you didn't say how. Okay, that's what I'm looking for, is the connections there. Okay, so conduction, convection, radiation. They're going to be big. They're going to be in any question about energy transfer. Globally, big picture, or small scale. On your review sheet, one of the questions asks you to design a structure that could keep food cold in a hot California desert. Okay, so if I want to keep something cold, I want to keep energy out. Okay, what are the three ways energy could get in?
Conduction, convection, radiation.
Right, if we're talking about energy transfers, those three are going to be a part of this. Here's the application part of that question. Once you realize those three things are part of it, now you have to think of how you can stop them. Okay, how do you stop radiation? Would I want something with a high albedo? Because that would be highly reflective. That would keep radiation out. Okay, all right. How do I keep it? Obviously, the air around the structure is just going to be hot because it's California. It's just going to be hot. How do I keep that sensible heat out? Well, then I've got to stop convection, and I've got to stop conduction. Okay, and that's what this terrible drawing is here. That's supposed to be insulation, right? How does insulation work? What does it do to the air? It traps it. Yeah, it doesn't allow it to move. Does that prevent convection? Does having little pockets of air everywhere also prevent conduction? How?
Conduction of three solids.
Exactly. Okay, you see where I'm going with this? It's an application. It's not just write down conduction, convection, radiation. It's tell me that I understand how these things work. Okay, and I understand how they apply in this situation. Okay, just writing down that I need to stop this or I'd make it white. Okay, fine, that's great. You'd make it white. Why? I'm looking for the explanation part of that. Okay, just saying I'd make it white and insulate it is like a 2 out of 5. Okay, absolutely you should do that. But the next level answer is why? What do those things do? How do they work? Everybody follow? Okay, that's the problem we ran into on the biology exam. Level of detail. Okay. Okay, and then global wind patterns. Okay, this was a pretty short lesson. There is a written response question about it, and there's some multiple choice about it. Okay, so, you know, there were the 3 wind layers, you know, the trade winds and the westerlies and the polar easterlies. But you're going to have to, and this is mostly a memorize and regurgitate kind of question, but you're going to have to tell me why the wind patterns are the way they are. What, did I start the recording again? What energy transfer mechanism is involved in wind? Conduction, convection, or radiation? Convection. Should that be part of your answer? Okay, there's another connection, right? Okay, convection only moves up and down though. It only moves hot air, cold air, hot air, cold air, but yet we've got winds going east to west. Why? Coriolis effect. All of this is going on, but the Earth is spinning underneath it. Okay, so it's like sticking your head out the window of a moving car. It's not necessarily windy that day, but it feels windy to you because you're moving through the air. Okay, the Earth rotates under its atmosphere. Okay, at like 1,600 kilometers per hour. Right? Luckily, the atmosphere mostly moves with us. Okay, but I mean it's not connected, and it doesn't move totally with us. It's moving vertically as well. Okay, so talking about how the Coriolis effect and convection, okay, how they relate to making those layers of wind and stuff like that, okay, that would be a big part of it. Is the jet stream a wind mechanism? What does it move again? Latent heat and moisture-laden air masses. Okay, again, that's the one. If people forget one, that's it. Okay, it's still an important energy mechanism because of its role with latent heat. Okay, it's not really a big part of why there are easterlies and westerlies. It's not really part of that, but it's a wind mechanism. Okay, questions on the wind patterns? And it was a pretty short lesson. Okay, after wind patterns, we talked about specific heat capacity. Now, specific heat capacity is that physical property of different materials that determines how much energy is required to change its temperature. Okay? Some materials have a low heat capacity, which means they heat up quickly. Other materials have a high heat capacity, which means they heat up very slowly. They require a lot of energy to change their temperature. One of those materials is water. Why is it so important that water has a high heat capacity? Does that affect anything that we talked about? Is there a connection that can be made here to something we talked about earlier? Cash is nodding his head. What can that connect it to?
It's a factor affecting climate.
Exactly. Which one?
Proximity to the ocean.
Exactly. Okay. We talked about how being close to the ocean regulates your temperature. Okay. It's because the ocean has a high heat capacity. That means it can give off a lot of energy to cold air and not change its temperature very much, but warm up the air, and vice versa. If the air tries to get too hot, the ocean can absorb a lot of its energy without changing temperature very much, so they always stay close to the same temperature, right? That's how heat capacity plays a role in a factor affecting climate. Those are the kind of connections that we need to make. Okay, so that would be, part of maybe another question or a multiple choice question. But then we also went over problem solving to do with specific heat capacity using E equals mc delta T. We didn't spend very long on that because after the stuff we did in physics, using that formula is pretty straightforward. Okay, how would you tell the difference between a specific heat capacity problem and a heating curve problem? Because they can give you kind of similar information. How would you tell them apart?
State changes.
That's the thing. Okay, in a specific heat capacity question, there won't be any state changes. Okay, the material, and the material probably won't be water. Okay, more than likely, I could, but I probably wouldn't. So it'll probably be a material other than water, and there won't be any state change. If there's a state change and it's water, it's definitely a heating curve question because that's the only kind of heating curve we've talked about. Okay, everybody with me there? All right. So there'll be a problem on that, 5-mark problem. Okay, write your givens, write the formula, manipulate the formula, plug in your numbers, show me your answer, 5 marks. Okay. And then there will be a heating curve question. Now, latent heat is not just a heating curve problem. Latent heat is, again, one of those energy transfer mechanisms that involves the water cycle and global energy transfers and the jet stream, okay? It's, again, one of those concepts that's in a lot of other ideas. Okay? But there will be a latent heat problem. So do you need to know that heating curve? Okay, you do have to memorize that. I'm not putting the heating curve on the test. Okay, the formulas are on the test. Okay, the numbers, the specific heat capacities, and the latent heat of fusion and the latent heat of vaporization, so LF and LV, those numbers are all on the test, but the curve is not. Okay, you need to know the curve, and you need to know what formulas to use on the different parts of the curve. Okay. Luckily, MC delta T gets used 3 times. Okay, so you really only need to know 3 formulas. Okay, anywhere where the line is diagonal, you're using MC delta T, because if the line's diagonal, there's a temperature change. You can only use MC delta T when the temperature changes. Okay, when do you use LF? When you're at the freezing point of water. Okay. F for freezing, so latent heat of fusion, okay, freezing starts at 0. Okay, LV stands for vaporization, that happens at 100. Okay, water boils and vaporizes at 100, so V for vaporizing. Okay, simple ways to remember it. Okay, and then the last thing we talked about were biomes. Okay, and we said there'd be a few multiple choice questions where I give you a picture and a description, and you've got to pick the right biome. And then, of course, there's the climate graph question. Okay, so here's the good news, and I think I said this before, but I'll say it again. The good news on this test is the unit's very short. There really isn't that much to know. Okay? The tricky part of this unit is it all interlocks, it all relates to one another, and you've got to find and remember those relationships and be able to explain them. That's the tricky part. Okay? This is actually a good test to have right before the final, because it's 2 things, for 2 reasons. It's very much like the final in that there's some mathematical stuff and there's some level of detail written stuff, just like your final will have. Okay? The other part of it is this unit, because it has less material, okay, should allow you to do pretty well on this unit exam and thus raise the hardest part of your mark to change, the unit exam part. Okay? Now, please don't misinterpret. I am not saying this test is easy. Okay? This test is the same level of difficulty as all your other tests, but there's less material on it. So you can really master that material. If you put the same amount of time into this unit exam as you did with ones that you did well on, then you should be okay. Okay? In fact, you should do better then because there's less to know. Okay? The tricky part is, can I make the connections I need to make on the exam? Okay? The review sheet has questions that are kind of like that, where you can make those connections a little bit, okay? But that's the key part. All right, questions from you guys? Anything you'd like me to go over in a bit more detail, okay, or cover again? Or?
Just 6, the latent heat, correct?
Okay, so like do another latent heat problem? sorry, I have 400 grams. It's kind of an important number, you need that. Okay, give that one a try. Okay, I'll give you a few minutes and then we'll go over it. Whoops. Okay, just the first like 2 steps of this question. Okay, we draw the heating curve. Okay, doesn't need to be any more detailed than that. Okay, if this first flat part is 0 where it melts and freezes, then that would be my starting point right there, slightly above it at 12 degrees Celsius. Right, I'm going for steam at 130, which would be the top of the graph. Right, how many steps is that? 3. I've got to heat the water to boiling. I've got to evaporate all the water, and I've got to heat the steam. Okay, I'll give you a few more minutes in case you were stuck. Okay, 400 times 2.02 times 30 degrees. Okay, so there's all of our calculations. Okay, so we did MLV for step 2, MC delta T for step 1, but we made sure we used the right heat capacity. We only changed it by 88 degrees. Okay, on this one, we used heat capacity for steam. We only changed the steam by 30. What do I do with those 3 numbers? Add them up. Plus. Okay, so we've got 1,076,080 joules. Okay, as our total there. Right, so like I said, most people get the steps right. Most people get the formulas right. If a mistake is made, it's almost always temperature change. Okay, so just be mindful of when it's water. Okay, people get the right heat capacity for water, but they forget. I'm only going from to 100 degrees. It's not water after that. Okay, it's steam after that. That's a different material. Okay. All right. Remember that next week, okay, we're doing final exam review. Chemistry Monday, Bio Tuesday, Physics Wednesday, unit exam Thursday, unit exam for Unit 4 on Friday. We'll review it. That'll be kind of the unit review for Unit 4. Okay, then we're done. Guys, it doesn't look like there's going to be any time during exams, like before you write, because you write like basically right away, to do any come in and see me. Plus, I have now been confirmed that I will have no desks. Okay, there will be no desks in my room during that time. So make sure you come with questions. We've got 1 review day for every unit. I honestly can't tell you the last time I had that much time for final exam review. So do your reviewing and come with questions during that time. Okay, and we'll get it all covered. All right. Reminders of a couple other things. June 14th, if you got any overdue assignments, June 14th is the last day to hand them in. 3/20 on June 14th is the deadline. Okay, and remember your final exam is June 20th at 1 p.m. Okay, so make sure that you are here in the gym, okay, for that. Okay, I will be in there supervising, so if you have questions, I will be there to answer them for you. And I'll try and duck out and get to learning support as well. If you happen to be in there, I'll try and duck out and just answer any questions if you have them. Okay? All right. So make sure you review on the weekend so you get the most out of next week. You got to drive the bus for the review. I'll drive you off a cliff if you let me drive. Okay? So you got to come with the right questions and keep us on the road. Okay? All righty. That's all I got for today, guys. I think we got like 30 seconds left in class anyway, so.